This is reaction prediction number 27, almost to the end. So let's look at our first one here, 0.1 molar barium nitrate. Now, this is a solution, so keep in mind this is aqueous. Is added to an alkaline, 0.2 molar potassium chromate. Well, to be honest, all the alkaline does is help promote this potassium chromate to occur. We don't know what the alkaline is, so there's not a hydroxide involved. These are just your reactants. Be sure to then write your products based on your net ionic equation. Okay, pretty easy one there. And identify any precipitates. Just name what that precipitate is. Should be pretty simple from that double replacement reaction. Number 2, concentrated hydrochloric acid. Obviously, that's HCl. Strong acid is added to a solid manganese sulfide. So you can't break that one apart. Just a double replacement reaction. Don't forget to eliminate any spectator ions in this reaction. Okay, pretty simple there. And then the second one says, what are those spectator ions? Pretty easy. This next one is a synthesis reaction. Iron, okay, that's the solid, so it's iron, the element, reacts with excess chlorine gas. So here's what that means. When it reacts with excess chlorine gas, that means when you get a iron and chlorine. Now, a lot of people want to break this apart because they say, well, this is soluble because there's a because it's a halide. Yeah, I get that, but the problem is chlorine, gas, hot iron filings, solid. There is no water for the iron chloride to dissolve in. So please do not make that soluble. It is not a set of ions. Now, how do I know? When it says excess chlorine, what that means is you get the +3 form of iron when you're going to write that compound. Okay, so that's our +3 form of iron when we write that compound. Okay, what type of reaction is this occurring? Well, we talked about that. Could actually call it 2 different types, but I named one of them. The other one deals with changes in our charges for that chlorine and for the iron and the chlorine as well. But we'll leave it as either one of those answers as being acceptable. Water, water, HOH, is added to a sample of solid magnesium nitride. And this will be written as a double replacement reaction. The only thing that I caution you about is one of your products will have nitrogen and hydrogen. And remember that nitrogen and hydrogen compound will have the negative written first. It should be a very familiar gas. And so you should hopefully be able to see that very familiar gas written appropriately. pH of the solution, acidic, basic, or neutral. Well, I just mentioned to you what your product was, that very common base, and so you can figure that out from there. Excess sulfur dioxide gas, right, that's obviously SO2, is bubbled through a dilute potassium hydroxide solution. And so in this, it's just going to be a combination of your hydrogen and your hydrogen, obviously, with your sulfur and your 3 oxygens to make an ion in solution. So this is just an ion that is a collection of a hydrogen, a sulfur, and 3 oxygens. Again, it'll be ionic, -1 on one side, be -1 on the other, and hopefully that's enough of a hint for you to figure out what that is. Resonance structures, we've done that, so hopefully you can have no problem with that. Aluminum metal is added to copper 2 chloride. Hey, remember those of us in honors from last year? This is the aluminum wire lab, just a single replacement reaction. Keep in mind there are some colors here. 2 color changes you could see. One is the solid silver that changes color when it reacts to make its new precipitate, or the copper 2 chloride, which is blue, and then the solution that it makes. So either one of those color changes would be acceptable. There is a major color change in the actual solution itself. But again, that's up to you, however you want to see that color change occurring, or I guess to explain that color change. Again, don't forget to eliminate spectator ions. In this case, I believe I see one of them. Eliminate that spectator ion, balance the reaction, maintain the charges that you see. Solution of manganese sulfate. So MnSO4, this is aqueous, and ammonium sulfide, NH4 2S, again, also aqueous. This double replacement reaction should give you a single precipitate as your product. All right, single precipitate as your product. And again, identify that that precipitate in solution. Dilute hydrochloric acid, right? We know what that is. Oops, let's write this the right way. Strong acid is added to potassium sulfite. And then hopefully you'll identify that intermediate. And intermediate just means something that immediately breaks down, and hopefully you can figure that substance out that will immediately break down to produce something, produce two species, one of them being a molecular species and the other one being a gas. Okay. I think that's it. I think we've gotten through everything. If you have questions about this, Reaction Prediction 27 due Friday, please ask.